For any three sets A, B, and C, the Cartesian product of A and B minus C, this is going to be equals to the Cartesian product of A and B minus the Cartesian product of A and C. Okay, let us begin. Now, in order to prove that this is a true statement, we're going to take the help of the condition that if A is a subset of the set B and B is also a subset of the set A, then this simply means that A is going to be equals to B, which means that we will have to show that the left hand side of the set is going to be a subset of the set on the right hand side, and also the set on the right hand side is a subset of the set on the left hand side. Okay, to do this, what we'll do, we're going to use the definition of a subset. So here the definition being, we can say that for all values of A belonging to the set A implies that A also belongs to the set B, then this statement simply means that A is going to be a subset of the set B. Okay, we're going to use this statement. So for this, we'll have to pick up an element in the set on the left hand side. Now, since this is a Cartesian product, we'll have to consider our element to be an ordered pair. So let's say the element is represented by the ordered pair A comma B. So let A comma B be the ordered pair such that the ordered pair A comma B is a member of the set the Cartesian product of A and B minus C. That's the difference of the sets B and C. Now, what does it mean? So when we extend this statement, this simply means that if we consider the first element of the ordered pair, which is A, this element is going to be a member of the first set, which is A, and the second element of the set, which is going to be the second element of the ordered pair, which is B, that's going to be an element of the second set, which is the difference of B and C. Okay. Furthermore, we can rewrite the set statement as A belonging to the set A, and we have the element B belonging to the set B, and a B cannot belong to the set C. That's the definition of the difference of two sets. Okay. Now, furthermore, we can rewrite the statement as, now as we can see here, this is a fixed. This is fixed. That means A is always going to belong to the set A. So we can rewrite the statement as A belonging to the set A, and we have B belonging to the set B. And we can also write A belonging to the set A and B not belonging to the set C. Now, what does it mean when we say that A belongs to set A and B belongs to set B? That simply means that the ordered pair A comma B, that is going to belong to the Cartesian product of A and B. And we have an element A which belongs to the set A, but another element B does not belong to the set A. So we can say that A comma B, it cannot belong to the Cartesian product of A and C. Now, when we combine this is simply telling us that the ordered pair A comma B, this is going to be a member of the Cartesian product of A and B, but it is not going to be a member of A and C. Now, we started out by considering an arbitrary element, which is the ordered pair A comma B. This belongs to the set the Cartesian product of A and B minus C, and we were able to show that that same element is now a member of the set A, the Cartesian product of A and B minus the Cartesian product of A and C. So if we combine this 1 and 2, or combining 1 and 2, we can say that the Cartesian product of A and B minus C is going to be a subset of the Cartesian product of A and B minus the Cartesian product of A and C. Now, coming to the second part, so what we'll do, we'll now show that the Cartesian product of A and B minus the Cartesian product of A and C is a subset of the set on the left hand side, which is the Cartesian product of A and B minus C. For this, again, we have to consider another ordered pair. So let's say X comma Y. This is an ordered pair which belongs to the set the Cartesian product of A and B minus the Cartesian product of A and C. Now, this statement simply means the Cartesian, the ordered pair X comma Y, this is going to be a member of the Cartesian product of A and B, and that same ordered pair X comma Y, it's not going to be a member of the Cartesian product of A and C. Fine. Furthermore, what does it mean when we say that the ordered pair x comma y is a member of the Cartesian product of A and B? That means that x is going to be a member of the set A and y is also going to be a member of the set B. And the ordered pair x comma y not belonging to the Cartesian product of A and C, that simply means that x is going to belong to the set A, because we've already considered x to be belonging to the set A. So again, we're considering x to be a member of the set A, whereas the y, the second element in the ordered pair, that cannot be a member of the set C. Only then we can say that the ordered pair does not belong to the Cartesian product of A and C. Now we can combine this statement and say that x is a member of the set A and we have y being a member of the set B and y not being a member of the set C. So that means we have x belonging to the set A, and what does it mean when we say that y is a member of B but not C? That simply means y is a member of B minus C. Now we have x belonging to the set A and we have y which belongs to the set B but not C. It simply means that the ordered pair x comma y, this is going to belong to the Cartesian product of A and B minus C. So we started out by considering an ordered pair x comma y which is a member of this set, and we were able to show it is also a member of the other set. So from this we can say that the Cartesian product of A and B minus the Cartesian product of A and C. So this is going to be a subset of the set the Cartesian product of A and B minus C. So let's call it number 4. So if we now combine statement 3 and statement 4, we can say that the two sets are equals to each other. So we can finally say hence from our statement 3 and statement number 4, from these two statements we can now say that the Cartesian product of A and the difference of the two sets B and C, this is going to be equals to the Cartesian product of A and B minus the Cartesian product of A and C. So we have successfully verified our problem.